ready to get microscopic and uncover a hidden world that's maybe a little too close to home.
Oh, that doesn't sound good. Should I be worried?
Well, let's just say it involves pests, crops, and some surprisingly sophisticated tech. We're diving into the world of soft-scale insects.
Ah, those tiny troublemakers.
hmm
I've seen firsthand what they can do to a citrus grove. Not pretty.
You weren't kidding about tiny. I was looking at some pictures, and well, let's just say I'm glad we're not actually shrinking down to their size. So, for those of us who don't spend our days examining leaves under a microscope, what exactly are we dealing with here?
Think of them as the ultimate moochers of the insect world. Tiny sap-sucking insects, usually less than a quarter-inch long. They latch onto plants, citrus being a favorite, and just drain them of their sugary fluids.
And that's bad. How exactly?
Well, for starters, it weakens the plant, making it more susceptible to diseases. But it's not just the feeding that's a problem. They also excrete this sticky stuff called honeydew.
Honeydew? That sounds almost pleasant, like something you'd put in tea.
I assure you it is not. Imagine a sticky, sugary mess coating your plants. Attracts ants like crazy, which creates a whole other pest problem. And it gets worse.
Oh, there's more. Okay, I'm intrigued, but also slightly terrified.
This honeydew, it becomes a breeding ground for sooty mold, which can actually block sunlight from reaching the leaves.
So not just a pest problem, but a potential fungal issue too. Double whammy. This is why I leave the gardening to the experts. But seriously, this damage, we're talking more than just cosmetic issues here, right?
Oh, absolutely. Stunted growth, deformed fruit, you name it, these tiny insects can decimate entire crops if left unchecked. And here's the kicker by the time you see visible signs of infestation. Often too late to salvage the crop. Early detection is key.
Which brings us to this Farmonaut technology you mentioned, monitoring entire fields from space. Sounds like something straight out of Star Trek. How on earth does that even work?
It's pretty amazing. They use satellites equipped with these special sensors. These sensors pick up on light that's reflected from the plants, but in wavelengths far beyond what our eyes can see.
Okay, so the plants are basically sending out signals. But how do we translate those signals into something meaningful, something that tells us, hey, we've got a soft-scale problem brewing here?
That's where the AI comes in. Farmonaut uses AI algorithms to analyze all that data from the satellites. They're basically comparing the light fingerprint of each plant to a massive database of healthy and infested plants.
So it's like having a team of microscopic detectives scanning your fields from space, looking for those telltale signs of trouble.
Exactly. And because they're looking at the plant's overall health, not just visible pests, they can often detect infestations weeks earlier than traditional methods.
Weeks! That's huge, especially when you're talking about a pest that can multiply so quickly. So what happens when Farmonaut detects a potential problem? Is it just a matter of hitting the alarm button?
Well, it's a bit more nuanced than that. Farmonaut doesn't just point out a problem, it offers solutions.
So it's not just, hey, spray everything with pesticides.
Yeah.
What kind of solutions are we talking about?
Right. It's all about targeted action. Farmonaut's AI, called Jeevan, considers everything, the satellite data, local weather patterns, even the specific type of soft scale detected. And then Jeevan comes up with a sort of personalized battle plan.
A battle plan? Sounds a bit dramatic for some tiny insects. But okay, I'm game. So what does Jeevan recommend?
It's all about a multi-pronged approach.
Yeah.
It might suggest cultural controls.
Cultural controls. Like,
No.
we're teaching the insects some manners, convincing them to move along.
Not quite. Think of it more like making the environment less appealing to the pests. Proper spacing between plants, for instance. That kind of thing.
So more air circulation, harder for those pests to settle in and wreak havoc. Makes sense.
What else? Then there's biological control, which is kind of like sending in reinforcements.
Okay, this is the part I've been waiting for. I read about this. Using other insects to fight the soft-scale insects.
Right.
Yeah.
Got it. It often involves releasing natural predators into the equation. Parasitic wasps, ladybugs, even predatory mites.
So instead of spraying chemicals everywhere, you're unleashing an army of tiny assassins.
Precisely. And it's a lot more sustainable in the long run. Chemicals can harm beneficial insects, pollute water sources, even lead to pesticide resistance.
It's like that old saying, fight fire with fire, but with bugs. But is it always enough? I mean, sometimes you need to bring out the big guns, right?
There are definitely situations where you need a little extra help. That's where Farmonaut's precision targeting really comes into play.
Right. They use weather data and AI to figure out the best time to apply a more targeted pesticide if necessary. So instead of carpet bombing an entire field. It's more like a surgical strike.
Absolutely.
Yeah,
Less pesticide overall, which is better for the environment and for us.
I can definitely get behind that. But with those billions in global losses you mentioned earlier, is this technology really making a difference? Any real-world success stories?
Oh, absolutely. There's this great case study about a citrus grove in Florida. They were dealing with a particularly nasty brown, soft-scale infestation, declining yields, poor fruit quality, the whole 9 yards.
Sounds like a nightmare for a citrus grower. So what happened?
They brought in Farmonaut. The system detected stress in the orchard weeks before any visible symptoms appeared.
Wow, talk about early detection.
Exactly. And that early warning gave them time to confirm the infestation and come up with a plan.
So they combined the cultural controls we talked about, like pruning, with the biological controls, the parasitic wasps.
Exactly. They were able to bring the soft-scale population under control, yields rebounded, fruit quality improved, and they significantly reduced their use of those harsher insecticides.
That's incredible. This isn't just about pest control. It's about protecting livelihoods, improving food quality, and doing it all sustainably. It's a win-win-win.
Absolutely. And it's not just about individual farms. Imagine the global impact if this technology were more widely adopted. Fewer crop losses, more food available at affordable prices.
Especially important as the global population keeps growing. But what about climate change? I imagine that throws a wrench into things.
You're right, it's a factor. Climate change is actually creating more favorable conditions for a lot of these pests, including soft-scale insects.
So hotter temperatures, changing weather patterns, it's basically giving these pests a leg up. Not good.
Yeah.
But Farmonaut's technology, it can adapt, right? And that's what's so amazing about this kind of technology.
Absolutely. They can adjust those algorithms,
Mm-hmm.
factor in new data on pest behavior and weather patterns. It's all about staying one step ahead.
It's amazing, really. Makes you realize that something as seemingly insignificant as a soft-scale insect can have such a ripple effect, you know?
It's a delicate balance.
Mm-hmm.
And as those pests become more resistant to our traditional methods, we need every tool in the toolbox.
Which brings up an interesting question. What else IS in the toolbox? Besides Farmonaut, I mean. What other innovations are out there?
Oh, there's some really fascinating developments in the works. RNA interference, for one.
RNA? What now? That sounds awfully complicated.
It's actually pretty cool once you wrap your head around it. Essentially, scientists are figuring out ways to use RNA interference to, well, silence certain genes in the pests.
Silence their genes. How do you even...
These genes, they control important functions in the insects, right? Growth, development, even reproduction. So by targeting those specific genes...
You can disrupt their whole system.
Yeah.
Without affecting other insects or the environment.
Exactly. Precision is key.
Yeah.
And it's a game changer, especially with pesticide resistance becoming such a concern.
Definitely a game changer. So what's next? What else is on the horizon in the fight against these pesky, well, pests?
Biopesticides are showing a lot of promise.
Bio. Those are the ones made from natural stuff, right? Like plants and whatnot.
Exactly. Fungi, bacteria, plant extracts nature's own arsenal.
Mm-hmm.
And because they're derived from natural sources, they tend to break down more easily in the environment. Fewer of those nasty side effects.
And they fit in with the whole sustainable organic farming movement that's really taken off. Consumers are demanding this, and it's exciting to see science rising to the occasion.
It's a win-win. Effective pest control that's also easier on the planet. Sign me up.
It's really incredible to think about. We've gone from these tiny insects, barely visible to the naked eye, to satellites in space, to manipulating genes. The future of pest control is sounding pretty high-tech.
It's an exciting time to be in this field, and it all goes back to something we've touched on throughout this deep dive, the interconnectedness of it all. What impacts those tiny insects ultimately impacts us.
And finding that balance, protecting our crops while protecting the planet, well, that's the ultimate challenge, isn't it? It's been fascinating to learn about all of this with you. Thanks for joining us and sharing your expertise.
My pleasure. Always happy to talk about the fascinating world of pests and plants.
To our listeners, thanks for joining us on this deep dive into the surprisingly complex world of soft-scale insects. Who knew something so small could spark such a big conversation? Until next time, keep those questions coming and never stop exploring the world around you.